This object is called a planet. But it might not be one. It's one of the largest planets ever discovered, 9 times the mass of Jupiter, orbiting a distant star 500 light years from Earth. But some scientists don't think it's a planet at all. And the more we learn about it, the less certain we become. Let's start with what we know. ROXs 42B flat is a gas giant, a bloated sphere of hydrogen and helium spinning in the darkness. It has no solid surface, no ground to stand on, just clouds and storms and crushing gravity. It's about 9 times more massive than Jupiter, the king of our solar system. And it orbits a young star in the constellation Ophiuchus. By every measure, it's bigger, heavier, and stranger than anything in our neighborhood. But size isn't the problem. The problem is what it is. By definition, ROXs 42B flat checks the boxes. It orbits a star, it's below 13 times the mass of Jupiter, and critically, it doesn't fuse hydrogen in its core. That last part matters. Stars burn hydrogen, planets don't, and ROXs 42B flat sits just below the threshold where hydrogen fusion begins. So according to the rules, it's a planet, but the rules were written before we found objects like this. Here's where it gets complicated. ROXs 42B flat is almost heavy enough to be something else entirely. A brown dwarf, failed stars that never quite made it, objects too big to be planets, too small to be stars. Brown dwarfs typically range from 13 to 80 times Jupiter's mass. ROXs 42B flat sits at 9. It's below the cutoff, but not by much. And mass isn't the only thing that matters. ROXs 42B flat orbits its star at a distance of about 157 astronomical units. That's more than 5 times farther than Neptune is from our sun day. It's so far out that some astronomers question whether it even formed the way planets are supposed to form. Planets are born in protoplanetary disks, clouds of gas and dust that swirl around young stars. Over millions of years, particles clump together. Small rocks become larger rocks. Larger rocks become planetesimals. Planetesimals become planets. This process works well close to the star, where there's enough material to build something massive. But out at 157 astronomical units, the disk is thin, sparse. There's not enough material out there to build a gas giant the traditional way. So how did ROXs 42Bb get there? One possibility is that it didn't form like a planet at all. It might have formed like a star, through gravitational collapse. A dense clump of gas in the outer disk simply collapsed in on itself, creating this massive object in isolation. If that's true, then ROXs 42B flat has more in common with brown dwarfs than with planets. It would be a failed star that just happens to orbit another star. This is the heart of the debate. Do we classify objects by their mass or by how they formed? ROXs 42B flat sits right on the boundary, 9 times Jupiter's mass. Formed, far from its star, possibly through collapse. It looks like a planet by the numbers, but it acts like something else, and it's not alone. In recent years, astronomers have discovered dozens of objects like ROXs 42B flat superjupiters orbiting at extreme distances, objects that challenge our definitions. HR 8799 B, C, D, and E, Beta Pictoris B, TYC 8998761 B and C. Each one raises the same question. What are we actually looking at? Some astronomers argue we need new categories. Planet and brown dwarf aren't enough. We need something in between. A term for objects that form like stars but lack the mass to fuse hydrogen. Others say the mass cutoff is all that matters. Below 13 Jupiter masses, it's a planet. Above that, it's a brown dwarf. Simple. But nothing about ROXs 42B flat is simple. The object itself is young, only 3 million years old. In cosmic terms, that's a newborn. It's still hot from its formation, glowing with infrared radiation. A temperature of around 2,500 degrees Celsius. That heat tells us something. It's leftover energy from when the object formed. Whether it collapsed like a star or coalesced like a planet, it's still radiating that primordial warmth into space. But age and temperature don't answer the fundamental question. They don't tell us what it is. ROXs 42Bb was discovered in 2013 using direct imaging. That's rare. Most exoplanets are found through indirect methods. We watch stars wobble from gravitational tugs. We measure dips in brightness as planets pass in front of their stars. But ROXs 42Bb is bright enough and far enough from its star that we can actually see it. A tiny point of light separated from its parent star, one of only a handful of exoplanets ever directly photographed. That visibility is a gift. It means we can study its atmosphere, analyze its spectrum, measure its properties with precision most exoplanets will never have, and every measurement deepens the mystery. Spectroscopic analysis reveals water vapor in its atmosphere, methane, carbon monoxide. The chemical signatures match what we see in brown dwarfs, not planets. Its luminosity, its temperature, its atmospheric composition, they all point towards something more star-like than planet-like. But the mass says planet. And in astronomy, we've always relied on mass as the defining characteristic. So which matters more? The mass or the method of formation? The number or the nature? These aren't just academic questions. They shape how we understand the universe. When we count exoplanets, should we include objects like ROXs 42Bb? When we build models of planetary systems, do we account for objects that form through stellar processes? The International Astronomical Union, the organization that defines these things, uses the 13 Jupiter mass limit. Below that, planet. Above that, brown dwarf. They don't account for formation mechanism because frankly, we can't always determine it. Formation happened millions or billions of years ago. We weren't there. We can't rewind time. We can only infer from what we see now. ROXs 42Bb forces us to confront the limits of our definitions. We created categories to organize what we observe, but the universe doesn't care about our categories. It produces objects that sit between them, objects that blur the lines we've drawn. And ROXs 42Bb might not even be the most extreme example. As our telescopes improve, as we find more objects in more distant systems, we're going to encounter stranger things. Some astronomers have proposed a mass limit based on deuterium fusion instead of hydrogen fusion. Deuterium is a heavy isotope of hydrogen. It fuses at lower temperatures and masses than regular hydrogen. The deuterium burning limit is around 13 Jupiter masses. That's not a coincidence. That's why 13 became the cutoff. But deuterium burning is hard to detect. We can't always tell if an object is fusing deuterium or not. So even that definition has problems. The truth is, nature doesn't work in discrete categories. There's no sudden switch that flips an object from planet to brown dwarf. It's a spectrum, a continuum of mass, temperature, composition, and formation history. We want clean boundaries because they make science easier. They let us organize data, build theories, make predictions. But the universe is messy. It doesn't respect our need for order. ROXs 42Bb is the proof. Right now, it's classified as a planet. It appears in exoplanet databases. It's counted in statistics about gas giants. For now, that's how we treat it. But one new measurement could change everything. A more precise mass calculation, better data on its formation environment, evidence of deuterium fusion. Any of these could tip the scales. And even if the classification never changes, the questions remain. What does it mean to be a planet? Is it about where you are or how you got there? Is it about what you're made of or what you do? ROXs 42Bb doesn't have answers. It only has questions. It hangs in the darkness, 9 times more massive than Jupiter, orbiting a star that's barely older than it is. A giant ball of gas and heat and mystery. We call it a planet because we have to call it something. But in the quiet moments, when astronomers look at the data, they wonder. They wonder if we're looking at the future of planetary science or the limits of our current understanding. They wonder if ROXs 42Bb is an outlier or the first hint of something we haven't conceptualized yet. The universe has a way of humbling us. Just when we think we've figured something out, it shows us an object like ROXs 42Bb flat, something that fits the definition but defies the pattern, something that's technically a planet but doesn't feel like one. And maybe that's the real lesson. The universe doesn't care what we name things. It doesn't care about our conferences and our committees and our careful definitions. It just keeps making objects that challenge everything we think we know. ROXs 42Bb flat is one of them. A planet that might not be a planet, a question mark hanging in space. For now, we call it a planet. But we do so with uncertainty, with the knowledge that we might be wrong. And in science, that uncertainty is where discovery lives.